The next subject we're going to discuss is a few calculations. One is utilization, and the other is going to be productivity. Utilization is how well are we utilizing our resources? How much of our resource are we using? As you've learned as we've gone through our capacity calculations and things like that, the video of the goal, what you're learning is there is capacity out there that we often don't even recognize that we have. All right? People take breaks and the equipment is down during that break. That's capacity that we've lost. Right? Maybe we stagger breaks or whatever. But this is utilization. This is how we talk about utilization. Are we actually using the resource we have? Think about a hospital and an MRI machine. MRI machines are very expensive. 20 years ago, when they had an MRI machine, they would use it from 8 to 5 when an MRI technician would be there. Nowadays, if you need an MRI, you may be called in at 10 o'clock at night, 11 o'clock at night, because they're making use of these things during the off hours. It's better to have 2 shifts of the machine being used instead of buying and maintaining 2 machines. So it comes down to utilization, how you can do it. Now, there are limits to that. People are not going to come in, let's say that you are over capacity at your dental office. People aren't going to come in at 3 in the morning to get their teeth done. So you may have to expand your dental office to be able to have this capacity during normal hours. But there, within those limitations, and you have to understand your own processes and your own customer base, we need to figure out what the utilization rate is. So utilization, as you can see on the slide here, is basically output divided by the maximum capacity. How much are we getting out of it divided by how much capacity we actually have. Now, I have an example here that I want to show you, and the example here is Floyd's Barbershop. Now, Floyd's operates for an 8-hour day. They have 6 barber chairs, and they have 5 full-time barbers. All right? How much of the capacity that they have are they utilizing? And the bottom line, you take a look at this, and what we have is, of course, utilization is going to be output divided by that maximum capacity. Now, what is the output for Floyd's every day? Every day, Floyd's has 5 barbers, and these barbers are going to be working 8 hours per day. All right? So our output is 40 hours of production every day. What's their capacity? Well, they could actually have 6 barbers working. They're only using 5 chairs. Because I don't care how good a barber you are, you can't be cutting 2 people in 2 different chairs. Right? You can't have 2 chairs going with 1 barber. So I have actually 6 chairs available, and it's available for the 8 hours that it's open. So I have 48 hours of production that I could do. I'm only using 40 of that 48 hours, so I've got about an 83.3% utilization. About 17% of my capacity is not being used. Now, a lot of you will say, well, why don't we go with 24 hours? There's 24 hours in a day. Why don't we go with that? Because, again, people aren't going to come in at 2 in the morning, at least not reasonable people, not very many people, are going to come in at 2 in the morning to get their hair cut. So the chairs are only available while Floyd's is open. Now, yes, he could increase his capacity by staggering shifts and being open 12 hours for the day. Maybe instead of being open from 9 to 5, he goes open from 9 to 7, adds another 2 hours to every day. Yes, that's another way to pick up capacity. If it's reasonable that your process can be used and utilized during that period of time. Now, what happens, say, in this case, we're assuming 2 things here, okay? We're assuming that they work 8 hours without a break, all right? We're also assuming that they are fully utilized during those 8 hours, so they are actually cutting hair continuously for 8 hours. What if we change this? They're still fully utilized when they're working, but now they take a half-hour lunch break every day. How does that change our utilization? Well, does it change our capacity? No. Floyd's is still open for 8 hours a day, so the chair is available. Granted, the person's not going to be working in the chair for the half hour he's at lunch. That doesn't mean somebody else couldn't. Floyd's is available. The chair is available for customers. So in this case, our capacity stays the same. We still have 6 chairs that are sitting there for the 8 hours that were open. We did not change opening hours. What did change is my 5 barbers now are only available for 7.5 hours each. All right. So what happens here is now we only have 37.5 hours of productivity. All right. And we still have the 48 hours of capacity. So now by adding a half-hour lunch to everybody, now our productivity drops to 78.13%. We're only using about 78%. We lose 5% of the capacity that we have available by adding that lunch hour. Now, we can sit here and argue back and forth about whether or not it's reasonable to give somebody a half-hour lunch or, breaks for other things. But the bottom line is we're just kind of making this a simple calculation. Yes, I could go into a lot of other things, fair labor laws and things, but we're just trying to show you simple ways to calculate things. And the bottom line is, where do you normally make a mistake here is, what is the actual capacity? The capacity is not 168 hours a week, because very few operations operate 168 hours a week. Even if they do, there's usually some type of maintenance that has to go on. So what is it? What is actually available? All right. In this case, 6 chairs for 8 hours a day, and then we figure out how much of that we're using, and that is our utilization. Now, when you take a look at this, all right, higher utilization means a longer lead time, and what I'm trying to show here is utilization rate is on the horizontal axis. Lead time is on the vertical axis, and what you see here is if your utilization rate is high, lead time is very high. Why? Because if I'm already utilizing, if I've already booked all of this time, it's very hard for me to find capacity to add a new order. All right? Let's pretend that we've got these 5 chairs being utilized, all right, and I add a 6th person. I can now add 17%. All right? If I go to 100% utilization, I've got all of these chairs booked, and I have every barber is already booked for the week. And somebody wants to come in for a haircut. Well, I've already got the entire capacity of it consumed. You're going to have to wait till next week to get a haircut. You have a longer lead time. Whereas if I have 5 chairs, if I'm only using 83%, let's assume that I do have a barber there. All right, so I've got 6 barbers and they're only utilizing 7 hours a day, or they actually have some downtime. Now I can fit another customer in. Maybe I can fit them in right now. Maybe I can fit them in 3 hours. But the higher my utilization, the longer it's going to take to squeeze somebody in. Now, when we look at productivity, this is a little bit different. Productivity is actually going to be output, and we usually do this as far as value of the output. So productivity is my outputs, and again, quite often it's measured in dollars, divided by my inputs, also measured in dollars. All right? If it's a single factor productivity, I only have one factor of inputs in here, then I can do it without using dollars. But typically if it's multi-factor, and we'll get to that in a minute, we're going to use dollars to try to make it. And what am I looking here? What am I looking at here as far as productivity? I'm trying to figure out how much I'm getting out of these inputs. I have this much money I've put into it. What am I getting out of it? And what's that ratio? All right? So obviously, I want to have my outputs worth more than the total of the inputs. If they're not, I'm not making money. All right? So if this ratio, if productivity is less than 1, I'm losing money. I'm getting less output than what I'm putting in. If productivity equals 1, I'm breaking even. And if productivity is greater than 1, then I'm making money. All right? I'm making some profit. Now, of course, it has to be a certain amount above 1 in order to make it worth my internal rate of return. So I've got some problems with that, and that varies from place to place. How much money do I have to be making? How big does this productivity ratio have to be in order for it to be worthwhile? All right? So let's take a look at a single factor productivity problem here. And what I've got here is I've got an insurance company. Now this insurance company processes 900 policies a week. All right? They have 3 employees that work 8 hours a day, 5 days a week, and again, no breaks. I'm just trying to make it a simple calculation. So in this case, my productivity is going to be those outputs. What is my output here? Well, I don't have any dollars on this, so I don't know what the policies are worth. So my output is 900 policies per week. All right? What are my inputs here? My inputs are, the only input I have is hours. All right? So what I end up with here is I have 3 employees, and they each work 8 hours per day, and they work 5 days per week. Now we've got to cancel out a few things here. We've got days that cancel out, we've got weeks that cancel out. All right? So we go through this, what we end up with is I've got 900 policies, and I've got 24 times 5. That comes up to 120 employee hours. So I've got 120 employee hours during this week. My productivity then is going to be, I got 7.5 policies processed for every employee hour that I work. This will tell me, based on what the volume through my insurance company is, my insurance office is, this will tell me how many employees I need to have. All right? We'll continue this with a multi-factor productivity. Now to do that, I need a little bit more room on my board. When I talk multi-factor productivity, this means that I have multiple factors going in. All right? So in this next problem, I've got multiple factors going in. So I've got a team of workers. And the output, all right, so my quantity that I produce is 500 units. The value for each one of these, all right, so we'll just call it price, is going to be $10 each. So my output in this case, so let's look at productivity here. Productivity is going to be output over input, just like we've done before. My output here is 500 units times the $10 per unit. Units cancels out. And my output is $5,000. Now it also says my inputs. I've got 3 types of inputs here. It says that I have $500 in labor. All right, there's my labor. I've got $1,200 in materials. And I have $300 in overhead. These are my factors. This is why it's called multi-factor. I have multiple factors in here. When you have multiple factors, it's normally going to be in dollars. All right? So I need to have everything converted to the same units. Add all this up. I got 500 plus 1,200 is 1,700 plus 300. So that's going to be divided by $2,000. The dollars cancel out, and I end up with a multi-factor productivity ratio of 2.5. Well, let's get back to what does this mean. All right, where did the inputs come in? The inputs were the value of what my output is. I made 500 units, they're worth $10 each, so my output was $5,000. What were my inputs? I had to put in labor, material, and I have overhead, $2,000 worth. And I get this ratio. What does this ratio mean? It means for every dollar that I put in, I can expect to get $2.50 back. It's a pretty good ratio. 2.5 to 1. That means I've got a pretty good profit margin on this product line.